Hello, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. Welcome to part 6 of this series on IOLink and RFID. In this video, I'm going to show you how to read and write to a tag, and I'll discuss some other settings and information shown in the user role menu and the process data section. This includes describing the memory types, start addresses, block lengths, and tag types. At the end, I'll cover some additional information regarding mounting, which can also be helpful. My RFID head is currently set to the default settings, and its correct IODD file has been uploaded. By default, my RFID head will automatically start trying to read a tag. This is indicated by a blue LED on the head, indicating that a task is active. And by default, it will only try to read 8 bytes of data. Also by default, we're operating in easy mode. This gives us up to 28 bytes of read-write data. If you need more, you'll need expert mode, which will not be covered in this video series. More than 90% of applications will be just fine with easy mode. Now, if I place a tag in front of the RFID head, an orange/yellow LED will light up, indicating that it has read the tag. In the last video, we saw the tag data under the process data section, but be aware, you can also see this data in the diagnostics tab. Alright, so let's head back over to the process data screen. I'll wait for it to load. We see that the read was successful. The read task is currently active. The data type length is 8 bytes, and here's what's been read off the tag. Again, we've already went over this information in previous videos, but these first 4 bytes are the header information, and the last 28 bytes are the read data available to us in easy mode. Now, what we haven't discussed yet is how to write to an RFID tag. So let's discuss that now. I'll start by explaining a few important points. Look down the screen to the next section. In the output process data section, there are all zeros next to the right data. This makes sense because we've not yet told the RFID head what it should write to a tag. So, how do you modify this section and tell the RFID head what to write to the tag? Well, beforehand, we need to adjust a few settings. First, I've told you that when the RFID head is set to auto start, its default value, it will constantly try to read a tag upon being powered up. If we want to write to a tag, we can't constantly be trying to read a tag, so auto start needs to be turned off. Next, we have to realize that writing to a tag could be dangerous depending on the application. If just demoing, changing write data is likely okay. But if doing something like changing tag data while the associated machine is running, you should not only have the skill, but the authorization to do so. This is why, in the web interface, you'll need to be logged in as an administrator. Once you have this authorization, you can enable the process data output write capability, so you can then write to a tag. So, those are the 3 steps that are necessary to write to a tag. Let's go do them now. First, I'll turn off auto start. Alright, so I'm going to start on the user role menu. In the previous video, I used the ISDU interface to change this. But this time, I'm simply going to click Edit at the top of the user role menu. I'll scroll down, and then I'll select 00 from the drop-down. As discussed in the previous video, that 00 is in hex. The H following the 00 is just another way of displaying a hex number. Click Save, and the blue LED should turn off on the RFID head. This indicates that it's no longer attempting to read. Next, I'm going to log in as an administrator. I'll select the Advanced tab, and I'll click on Accounts. And I'm actually already logged in as an administrator. So either way, just make sure that you have an admin password set up and that you are logged in. Now we can head over to the Configuration tab, click on Miscellaneous, and now that we have the rights, we can click on Process Data Output Writing capability, which I'm going to enable right now. Alright, so now we have the ability to write to RFID tags using the web interface. Let's head over to the port page under the attached devices. And if you navigate to the process data section, you'll now see that there's an edit button. And this will give you options under the output process data section. So now you see, you can not only read an RFID tag, but you have the option to write to an RFID tag as well. Now, if I click read, similar to when auto start is enabled, it will constantly start looking for a tag to read. Again, indicated by a blue LED, which basically says that a task is active. However, let's select write. I'll click save. And if you've watched the video covering the HTML document, you should be able to understand why the first byte, or octet, changed to a 02. Alright, so I'll bring back up the HTML document and find the output process data section, because that's where we were just working. And we were in easy mode, of course. Sure enough, since I know binary, I know that sub index 2, or write, is true. It's being executed. Again, if you need help understanding this, refer to the video covering the HTML document. We also see that no matter what, the header information, or in this case, the first 4 octets or bytes, will only have information in the first octet. And then the rest will be comprised of write data. Now, let's indicate what data should be written to the tag. Up to this point, we're used to entering commands in the ISDU. And you can see that that's still an option at the bottom. But now, we have something new available to us. A process data output interface. This is where we can enter data the RFID head should write to a tag. So again, we know that the header is comprised of 4 bytes, and just like the ISDU interface, this data needs to be entered in hex. As discussed in the last video, using an online converter may be helpful. So since I know that the header should be 02, which tells the head to write, followed by 000000, I know that any bytes after the header will be write data, again up to 28 bytes. My device is still set to the default setting, which is 8 bytes. So even though 28 bytes are available in easy mode, it will only write 8 bytes. You can see the user role menu to adjust this amount. By the way, if you type in a header of 00000000, it will deselect the write option if you've already selected it. The first byte needs to be a 02. So now I'll add some write data. After the heading, I'll type in 01, 02, 03, all the way up to 09. Again, I'm entering this data in hex, so for example, 09 is representing 1 byte of data. And then I'll click set, and then I'll refresh the screen. Now, if I place a tag in front of the RFID head, and I see that the orange LED has flashed on and off, I know that the first 8 bytes of data were just written to the tag. So now let's click Edit, and we'll switch from the write command to the read command and click Save. The blue light will blink off real quick, indicating it's going from a write task to a read task. I'll place the tag in front of the RFID head and I'll click Refresh. And we see that the read was successful. And sure enough, there is the data that was written, up to 8 bytes. So now, if you're wondering, why didn't it go up to 09? Where's that last byte of data? Well, remember, our RFID head is currently at the default setting of only 8 bytes. So it's only going to write those first 8 bytes. So in this case, it's going to leave off that 09. Now this tag actually already had information written to the first 28 bytes. And I can prove this by clicking Edit and changing the number of bytes under Read Task to 28. And click Save. So I'll go back over to the Process Data section. And now you can see the 8 bytes, which I just wrote, and then the data which already existed in the other following 20 bytes. All right, you now know how to read and write to a tag. I'm now going to cover a few more items seen here in the user role menu and the process data table. So let's start by taking a look at the user role menu. First, on the user role menu, I see that I have two options. I can either read user memory or the UID memory. So what is UID? It stands for unique identification, and more likely than not, it's comprised of 8 bytes. This read-only code is determined by the chip manufacturer. The user can only read it, and it cannot be changed. So, for the UID, you're not required to set the number of bytes or start address. I'll talk about these soon here. And on the other hand, the user memory is what you can use specifically for your application, whatever data you want to keep track of. It can be both read and written to. Indicating the number of bytes and start address parameters is required. So how does this start address come into play? This just specifies where in the data we'll start reading. It's like if I have a book. You can choose to skip the introduction and just go into the story, or maybe start at chapter 5. The point is, you can choose. Now, this adjustable value depends on the block length of the RFID tag. So for instance, looking at my tag, I have an IQC22, in which the chip inside is made by Texas Instruments. If I look at the last column, I see that the size of the memory block is 4 bytes. So what this means is that I can jump to any location in my user data as long as it's by 4 bytes. So for example, if I want to read 28 bytes, starting on byte 12, I can do that. But I couldn't do it on byte 11, 10, or 9. So while this table is up, I see that on my tag, the read-only memory is 8 bytes. Again, like it is for all the tags here. And there are 256 bytes of user read-write memory. I hope you see that since I have 256 bytes, I could even start reading data at the relatively high starting position of, let's say, 200. Again, this is okay because it's a multiple of 4. You can see that other RFID tags have different block sizes of either 8 or even 32. The tag with a block size of 32 would need expert mode due to the 28-byte limitation in easy mode. And as you can see here, we can interface with a very large selection, if not most, of the high-frequency RFID tags that exist out there. In addition to the start address, this block length specification is also true for how many bytes we read or write to a tag. And as you can see, we can only write to the user memory. Next, by default, tag type is set to 20. This guarantees that any of the ISO 15693 tags shown in this table again will be read. We do, however, recommend selecting the tag type that you're using. If you're having trouble reading or writing to a tag, make sure that you've not selected the wrong tag type. If the wrong tag type has been selected, or if you simply left the default value of 20, the tag could still be read or written to. It's just that the experience may not be optimal. You'll gain more control over the application if you select the tag type that you're using. If I want to change, I can simply click Edit. And since I'm using the IQC22 tag, I'll select 22. Easy as that. Next, why are there asterisks? An asterisk next to RW, for instance, means that that parameter is not included in data storage. Remember that this means the parameter can't be downloaded between the IOLink device and the IOLink master. So, if you want to quickly replace a defective IOLink device or configure multiple IOLink devices with similar parameters, you would still need to update this setting separately. And if a sub-index has an asterisk next to it, this means that the sub-index is not sub-indexable. And this is really only important when using the ISDU interface or programming with your PLC. Alright, so real quick, some additional information about mounting your RFID head. First, for flush mounting in metal surfaces, a lateral minimum distance X to metal, and a protrusion Y above the mounting surface must be observed. And when mounting several RFID heads next to one another, a minimum distance Z must be observed. This distance prevents the RFID heads from interfering with one another. Alright, so there are the basics of reading and writing to a tag. This rugged, powerful, and simple to use RFID system has a great price, and the web interface makes things really simple. I've seen a lot of customers starting to use IOLink, so I'm really proud that we're not only leaders with this technology, but we have really high levels of support and knowledge. If you remember, we were there at the beginning of IOLink's development. And of course, our RFID products are standards in the industry. In this video series, I've only scratched the surface of what can be done with IOLink. So if you can dream up an application, trust me, our passion is showing you how to make it work and providing you with exactly what you'll need to do it. Again, my name is Michael McCabe, Product Manager for RFID at Pepperl+Fuchs. And as always, remember that Pepperl+Fuchs is a leader in industrial automation. So click the subscribe button below to see the new industry-leading products that we come out with. And if I did a good job on this video, please click that thumbs up button so others can find it more easily. Remember, if we don't tell YouTube what's important by giving it a thumbs up, we're going to keep seeing only those shocking and crazy videos which can be fun, but they're not helping us to become the intelligent professionals that we aspire to be. Thanks, and I'll see you next time.